Welcome to the video lecture for laser and spectroscopy for third year BSc Physics. The unit is second unit. The topic is helium and neon laser. Myself, Dr. Kavitha, Professor Department of Physics from Dr. MGR Educational and Research Institute. Topics to be covered: history, characteristics, construction, principle and working, limitations, and finally applications. History. The helium neon laser was the first laser to be operated successfully and was fabricated by Ali Jevon and his co-workers in Bell Telephone Laboratories in USA in 1961. Characteristics. It is a 4-level laser, therefore the population inversion can be easily obtained. It works in continuous mode. The power output of helium neon laser lies in the range 1 to 50 milliwatt with input electrical power of 10 watt. The laser is capable of supplying continuous laser beam without need of elaborate cooling arrangement. The light from the helium neon laser is more directional and much more monochromatic as compared to that from solid state laser. The helium neon laser employs electrical pumping. Construction. The helium neon laser consists of a long and narrow discharge tube of length 25 cm to 100 cm and diameter 1 cm. It is filled with helium and neon gases at a pressure of about 1 millimeter of mercury and zero point 0.1 millimeter of mercury for neon. The gas mixture of helium and neon forms a lasing medium and is enclosed between a set of mirrors, forming a resonant cavity. A stationary glow discharge is excited in the gas by applying a few kilovolt DC supply. Principle and working. In this laser, the neutral neon atoms form the active laser material while the helium acts as a buffer gas and is used to selectively populate the levels of neon. When the discharges pass through the gas mixture, the electrons near the cathode are accelerated towards the anode. Depending upon the applied voltage and pressure of gas, the accelerated electrons acquire enough energy to excite the helium atoms to 21s and 23s states. The 21s state and 23s states of helium have relatively long life, since the only lower lying state is a singlet ground state 11s and no transition from states 23s and to 21s is optically allowed. These metastable states of helium nearly coincide in energy with the 3s and 2s state of neon. The closeness of levels indicates that collision of second kind are effective in resonant energy transfer from helium atoms to neon atoms. The probability of this energy transfer is very high since the 21s state and 23s state of helium are metastable. The excitation process can be represented as the helium when it reacts with the electron, it goes to the excited state, this helium star. The helium star reacts with the neon, the helium comes to the ground state and neon goes to the excited state. These excitation processes show the pumping mechanisms of a helium and neon laser. The 3s and 2s bands of neon play the role of upper laser levels, while the 3p and 2p are the corresponding lower levels. The main transitions are 3s to 3p and 2s to 2p and 3s to 2p. The lower lasing levels 3p and 2p are relaxed to 1s levels by spontaneous emissions. However, 1s level is metastable level and affects the efficient working of the laser. This problem is minimized by reducing the diameter of the discharge tube. Since 1s state is metastable, the neon atoms in 1s state collide with the walls of the discharge tube and gets de-excited to the ground state of neon. This cycle continues and the helium neon laser gives out light continuously. Limitations. The mirror used in the internal cavity laser get eroded by gas discharge and have to be replaced. The other configuration as shown in the figure using external mirror cavity provides greater flexibility. However, external mirror causes a loss of light energy due to the reflection at the end of the discharge tube. This can be avoided by using Brewster's windows at the two ends of the discharge tube. When such windows are used, the output laser beam is polarized in the plane of the figure. The spherical mirrors in the focal arrangement, that is, the cavity length is equal to the radius of curvature of each mirror. In this configuration, the diffraction losses are minimum and the alignment is much less critical. Applications. They are often used in the integrated barcode readers. Helium ion laser used in laser surgery to position the powerful infrared cutting beam. Surveyors take advantage of good quality of helium ion laser beam to take measurement over long distance. Thank you. If you are having any doubt, ask me.